Start streaming. Hey, we're gonna do something totally different today. I'm here with our intern, Anna, and Anna has been doing some awesome things at iPad Rehab. Anna, how long have you been with us?
I've been employed for 2 months.
2 months?
And I was coming once a week for about 6 months.
And what stuff have you fixed like this week?
A bunch of iPads. I've been doing
iPads.
screens.
I heard they were like not user serviceable.
Yeah.
So you did. I know you did an iPad 4 plus a dock this week. What else?
Another iPad 4 plus a dock. A bunch of disassemblies for Mark to do.
I know you fixed my daughter Maisie's iPad.
I did.
And she wrote you a super cute thank you note, which I have to bring in. I keep forgetting which I will do. So one of the projects you've been working on, tell us about the Dongle Dangle project. So Dongle Dangle has been coming and going for a while. We've had, this is the second batch of dangly dongles. Do you say dangly dongles or dongle dangle?
Oh, I don't know.
Do you try to avoid saying either one?
I don't think I've ever said either.
So the word dongle, I remember when I was in grad school, when I first came across my first dongle. And it was a dongle for this like gene sequencing software. And a dongle is a thing that you connect to a computer by USB that is a license key for some piece of software. So that makes it so that you have to pay to use it and kind of can only use it on one machine. And then you have to take the dongle and move it around, which is really irritating. So in our industry, you've seen us use the ZXW dongle.
Yep. And
you just tore one up.
I did.
Yes. So this is the USB dongle. This is our old ZXW dongle. Rest in pieces. Where's the little pieces of it?
In the sand.
Oh, in the sand, of course,
yes.
As is safe. So this is cool. Who wants to see what it looks like inside the ZXW dongle? Here, let's see if we can stick it under the microscope, and I will make a microscope happen like that. Can you find it under there? All right. Paul says, hi, guys. All right. Yeah, look at that, guys. It's got the this is the ZXW USB dongle, now defunct and has been replaced by username and password. If you need a USB, or if you need a ZXW username and password, go to store.ipadrehab.com and you can get your ZXW subscription renewed. I like how it has this little like time capsule looking thing in there. All right, so that is the magic of ZXW. So we are going to have Anna tell us about her Dongle Dangle project.
So we got a bunch of dongles.
Yes.
Dongles that were not dangly.
You can stick one under hand cam.
Okay.
There you go. So that's a sad, sad dongle that doesn't dangle.
Yes.
That is sad.
We pried it out of this teal plastic to expose the board, and they had the USB.
That's how it came out. Now, what was wrong with that? Like, why didn't the guy just use his dongle as dongles are directed?
He was claiming that it was breaking.
Okay.
So because it's stiff, it breaks when you plug it in too many times, I guess.
Yep. I remember that. Oh, I remember the software. It was called Sequencer. The Sequencer dongle. Never leave home without your dongle. It was very irritating when you got somewhere and you needed your dongle, and if your dongle was missing, then that is a bad day waiting to happen. So dongle breakage is a real thing. You do not want to break your dongle for sure. All right, so they were breaking their dongles, and you thought, if I make their dongles dangle, then...
So they sent us a bunch of these cords that looked like they just chopped off a USB extension cable. Mm-hmm. So we can resolder these 4 wires in place of the pins and make a dangly dongle that doesn't break.
Dangly dongle. Awesome. And are those, so you guys made a bunch of these earlier, and the guy liked them and he ordered another set of 12?
Mm-hmm.
All right. Now, what I like about this project is that when you get really specialized for microsoldering, there's, you got all this equipment, and like these guys that just came in, what would I come in here for? Well, if you have anything that's like super tiny that you need to, go back together. So we fixed a lot of what we call kind of like fix-out stuff. So we fixed, did you know the bowling alley machine? Like, we fixed the thing that oils, an automatic bowling alley oiler. And I fixed a scale from the Seven Bridges farm, I think it was, like a weighing of the cow. Like they had a similar kind of thing, like small, tiny wire break fix. The guys that make the malt, a malt house, which I learned all about. So you get to know people; it's really fun. Yeah. And so look for ways. Just talk to people. What else do you have around your house that's broken? Because there's a lot of break fix stuff that you can just solder back together if you have all the right stuff. So let's have at it. So let's watch Anna make that dongle dangle. All right, so we're gonna go to microscope cam. All right, so you can just look right down the microscope and kind of just use that as normal. So here we are under the microscope. 4 a.m. in Germany. Captain Marco Hawk says, an extension for your dongle, a stiff, non-dangling dongle. Don't break your dongle. Make them dangle today. Yes. It is 6:30 a.m. in Iran. It's 3 a.m. in Portugal. It's 4 a.m. in Germany. It's 10:04. Is that true? Yes, it is. It's 10:04. There you go. You can grab that. Is it in focus for your eyes under there?
Yes.
All right. So USB interface is a universal thing, and USB has usually positive, negative data, and data 1, data 2. Move it up a slight bit so that we can see you. Now, had you ever soldered before coming to work at iPad Rehab? Is that something that you did a little bit, or what?
Yeah, I did a little bit of soldering for my robotics team. No micro soldering, just soldering wires together for motors and batteries and stuff.
Do they have like soldering like equipment and stuff over there?
We have a soldering iron. Yeah.
All right. How to fix dongle dysfunction. I like it. So we were talking with one of the students today who is having a tough time with employees and training and things like that. And he was saying, where do you find quality people that are really capable of doing this kind of work? And we said, you go down and you talk to the high school robotics team. Yeah. So that's how we that's how we found Anna. And I think there's a lot of kids that are in that community that would have like a strong aptitude and strong ability. So Anna's been here, and she's readily able to just pick things up, figure things out for herself, and be a total fixer. So if you are looking for how to attract local talent, there is one problem though. I kind of feel like Anna's gonna go to college. Is it true?
Yes, probably. I could drop out of school and just fix.
Wait, what? iPads. Is that an option? Wait,
yay! According to Sunday, it's an option.
Going to college. Yay! What would your mom and dad say if you said, you know what, I decided to just kind of, hang out at iPad Rehab for a while?
I mean, if I had a job, I think they'd be okay with it.
Really? All right.
If I had a plan.
Right. Mom and dad are on chat. They say absolutely not. All right. So let's go back to these last couple wires. So you're gonna use flux, which helps to it helps with the wetting process. Somebody was asking what's the flux for, and it helps for the metal to actually form a chemical reaction and bond with the pad. Yeah, scoop that little dude in there, and it helps to prevent oxidation or remove oxidation. Oxidation surprisingly can kind of happen just sort of instantly, and that's the deal. So what are your thoughts on the next project that I would like to put you on? So Anna does all sorts of fun stuff around here, and what we need for her to work on next, awesome, is we need to do a really similar project to this one, but we need her to figure out how to make a charging cable catch on fire.
I didn't know that was specific to me.
Oh, yeah.
That's exciting.
Well, yes. I mean, it's going to be the funnest project we're going to be doing all week. We got 1 week to come up with a charger that we can make catch on fire at will. Do you think that you can do it?
Sure.
Sure. Awesome. There you go.
Oh, man.
Travis wants to know, what are we making? We are making a dangly dongle. How's your dongle going? Is it going to dangle?
There's a pad that's lifted up.
Okay, let's take a look at that lifted up. Now, I understand that you guys had to troubleshoot some of this. So you had to troubleshoot some of them initially. Here, let's swap you to this tool, right? Mini hot tweezers, and that can help with that. So let's pull it over and take a look. So what's important is that we have, kind of a connection. If it has a strong electrical connection, which you can measure, then we're going to put some epoxy on that so that it can stay down. Okay. So we would clean the flux off. Does it have a strong electrical connection? It looks like it does.
Yeah, it looks like it's still intact. It's just kind of
okay. Another thing that you could do would be to just kind of move that red wire up a little bit, and you could. You could even tear that whole pad off and just kind of move that whole structure up if you wanted to. All right, okay. But for now, let's hear about what else goes wrong with these dongles. Didn't you guys have to do some troubleshooting with some of them that didn't work because of their kind of being dropped and banged around and twisted and bent and not hanging on too well?
Yeah, so we found that most of the time when one of these wasn't working, it was because this L1 filter was bad.
Well, how did you know, how did you guys know that was a filter?
Mark told me.
Because Mark told you? All right.
Christy told me.
Because Christy told you. All right, so let's look at that structure. And you can see it has L1, D1, C1. L is probably a symbol that means inductor, where C means capacitor, and D probably means diode. That's just a guess, right? Just from looking at it. So that's a clue that a filter is in the class of inductors, and inductors generally have a convention of starting with an L. And then we can kind of read the board, and we can see these traces on the board, and we can see that a capacitor here, C2, has 1 foot on ground, which we can just kind of read from the board. This giant area is ground, and then it has this other foot that kind of goes on this line up here. And then we can kind of see this chip and see, okay, we've got a trace here. These things are fairly simple, but for L1, this component L1, which we think is probably a filter, we can see that it has the shape and structure and styling of a filter, which is just a fancy wire that acts like a fuse. And it has you can see that the one pad goes through the wire and it becomes the other pad, so it's not connecting to anything else. Okay. So these are commonly used at the sort of end of circuits like this that would be facing the external environment. So how do they go bad? They are similar to a fuse, and if something happens where they're either knocked off or some sort of electrical transient short to ground that makes electricity go through the filter too fast to get to a short to ground on the other side, that can make the filter just get too hot and it will melt. So you think that's what's going on here, right? Okay, so what are you going to do then? So you measured this and it does not have continuity, right?
Yes.
All right, so you measure this and it does not have continuity.
Yes.
That's Anna's lying face, everybody. It's permanently on YouTube. Guess what? We measured it, totally has continuity. Boom. through it. Here comes the bus. Beep, beep. So, but a lot of them did. This one, which is the only one left, we're like, oh, that filter's totally fine. But we're going to show you what it looks like anyway. I think you feel a lot better when you tell the truth, Anna.
Yeah.
Yeah. All right. Now redemption time. Okay. So this one does have continuity. We're just going to have Anna change the filter just for an example. Do we have any filters around here? Back there?
Back. Yeah.
Okay. Which one? I don't know which one you've been using.
iPad backlight filter.
I don't know where they are.
They're in
I gotta go on a hunt.
Yeah.
All right. Here, we'll look here, and you can tell us about how you're gonna approach this job, and I will go hunt down a filter.
All right. So I take the.
And now everyone will know this is Anna's lying face. This is the. I think it's.
Okay.
Yeah,
So I take the mini hot tweezers. Clean them.
Oh, hey, there's Moses from the course in chat. What's up, Moses? So, Anna, do you feel, this is probably a big first for you. When Moses is in this room, you are no longer the youngest person in the room.
Oh, yeah.
Yeah, so then you're like an old lady. Because he's only 15.
Wow.
Yeah. And you're 17, right?
Yep.
Yes.
So,
All right, so are we done? I missed it. Oh, here's the filter strip. I dug them up.
I lost the old one.
A lot of people in chat are getting really bothered. Please resolder the red wire so it doesn't pop off. I think you should not resolder it, and in fact, we should just do a giant blow up because it's like the opposite of oddly satisfying. It's oddly irritating.
Oddly dissatisfying.
It's oddly dissatisfying. Yes. And I think that we're not going to resolder it. What we're going to do is we're just going to epoxy that pad later. Because it's fine. It's electrically connected. We can't see. You got to pull it down a little bit. Or just look. Do you want a hand cam instead?
I think I'll use a microscope.
Okay.
It's just way out of. Or do you want a hand? Can I use the microscope and hand cam, or does that not really work?
Probably not. Just do whatever feels most natural. All right. Okay. As a beginner, what is the sand used for? Yes, I think that Anna would love to take that question. What is the sand for?
Used for?
Yeah,
I should have paid better attention.
Sand right here. Sand, lots of sand. So what is it for?
In case anything goes wrong when you're working at Apple,
or
when you're a certified Apple technician.
So tell me about the training that you received here on battery safety. Was it you had to watch a parody video of of two people kind of making fun of battery safety?
You mean my training 5 minutes?
Yeah,
yeah.
It might have been 5 minutes. Whatever.
Yes.
On the job training. All right. Did we do the filter? Is it done?
No, I need to.
All right. Are you a fan of the mini hot tweezers?
I am.
Have you used those before or not?
I've only used them for this job, but they make this job easy.
They do. They are like totally designed for this job. We will kind of make that a little bit better. All right. There we go. All right. Hi, Jessa says tested to destruction. Yes, I thought this was a genuine repair. It is a genuine repair. We are making we're making a dangle that did not dangle before. That dongle didn't dangle, and now it does dangle.
Okay, I think that's.
Is it all good? What's that dude up at the top? Is he always there? This
Which
guy
dude?
that's like next to this cap. He looks like that's the old. Is he
Oh,
supposed to be
that's
there?
where it went. Yeah, it's not supposed to be there.
Yeah, let's snake him out of there. All right. I do like the old like circuit boards. I put together this like really cool Christmas tree one where you had to solder on all of these things. All right, very nice. Okay, so we're gonna clean up the flux and maybe dip it in the ultrasonic, and then we'll come back. And I think that one of the things to learn when you're learning how to do the kind of stuff like this, when you're brave enough to say, sure, I'm gonna live stream on a YouTube channel on how to do this job, is that we're meant to show YouTube, how do you handle things that are kind of a little bit unplanned? Like, okay, this pad lifted, so what am I gonna do about that, right? Mm-hmm. And so we talked about different options. One is we could just cut that pad off, and then we could scrape the trace and move up and kind of make the pad move up. Mm-hmm. Or we can do, since it's electrically sound there and it doesn't really look like there's a crease, then we can clean it, leave it as is, and we can apply epoxy to bond that pad physically to the rest of the board. All right, so then what's the next step after that? Do you put it back in the case?
Yes, then we put it, kind of wiggle it back in.
And cam. Yes. And cam.
So we wiggle it back in like that, and then we just use like a 2-part epoxy to kind of
epoxy to get the pad down, and then to also.
And we just fill it up with epoxy so that it doesn't come out.
All right, there we go. All right, very good. So you have done. I see a whole bunch of these over here. So fantastic. And now we're gonna finish up by telling everybody about your other project. So I like yesterday, I said, mm-hmm. Hey, Anna, I want you to wave your magic wand and come up with a adapter so that we can make for our for the Seek camera. So this is the thermal camera that we use a lot. So this thermal camera is the Seek Compact Pro that we sell on iPad Rehab Supply. And it's fantastic, but it works way, way, way better if you add a macro lens. Now the macro lens is, you've got to attach it to the actual camera. So I gave Anna the challenge of making a way for that to kind of stick on there. So tell me your thoughts. Like, what did you do? Because I really don't know. I just see that you have magically come up with something all by yourself. So tell us how you made that.
So this is a 3D printed part. Basically, I made a cylinder that will fit over this camera, and then I put a little inset that fits the macro lens. So that sits nicely in there like that, and then it snaps over the camera like that. Now one challenge that I had was this camera is tapered kind of in the wrong direction. So it means that anything that you put on, anything that you make that's tight enough to fit around the bottom won't go over the top. So I added a taper inside of this, but then I created little relief cuts so that it has enough flex to snap over the larger diameter.
I'm pretty sure that I just suggested that you make up something yesterday.
Yeah.
That's really incredible. How did you know how to do that? Like, how did you even begin? Like, how does somebody that might be watching the channel who's also, who's also 15 or 17, how do you start? Like, what do you do first? How did you learn how to do that?
Well, I'm on my high school robotics team, so one of the things that I do there is a lot of 3D printed mounts. So a lot of the stuff is kind of similar, like this thing has to attach to this other part that you have. So you take dimensions of the part, you figure out how it can stay on. So this has like a nice sort of grippy exterior. So I figured if I make something that's tight enough, then it'll just kind of hold itself on, and I don't need to worry about making little clips or something.
See why Anna can't go to college? She needs to stay right here, right? Well, that's really remarkable. Now let's try it out. I want to see how it works. So So I'm going to show you how we use the thermal cam, and let's kind of do it before and after with this macro lens. All right. So let's grab this. This is a board that I had to dig up one that actually had a short. We'll just leave it right here. So let's go here, and we are going to. Balzette would like you to know that Balzette would have tried a water bottle cap first. Well,
good idea.
Yeah, well, we'll find out.
It does look like a water bottle cap. You know,
yeah.
You can make it work.
I don't know. I think it looks pretty exact. So how did you measure it? Did you use like digital calipers?
Yep,
or
I used
what?
digital calipers, and there was some guessing and checking because you need to. It's hard to know like how much allowance you need because obviously if I think the diameter was like 21 millimeters, so if I printed something that had a 21 millimeter hole, it wouldn't fit, so you need to make it like 21.4 millimeters. So there was some guessing and checking to determine
I'm just
the
impressed that
exact
you got
size.
any kind of print to stick to the bed.
Yes, that's 3D printing in general is a challenge.
Well done. All right, so I've connected to our DC power supply. This is an iPhone 6 board, and not that. There we go. So this is an iPhone 6 board that is connected now to DC power. And we can see that DC power over here, audience can't see it, but it is consuming 174 milliamps, which is kind of low, but not zero.
Okay.
So it can be really difficult to detect a short, so if you touch it with your hand, like does it feel hot to you? Like would you be able to find that with your face?
I don't know.
So, it's not very hot.
Not really.
All right, so now we're gonna use the just straight up thermal cam. So hopefully we're gonna be able to just kind of show everybody. We're gonna plug in. This is the Seek Compact Pro that I have the iPhone model, and we also have the Android model. So we're gonna plug in the iPhone model and pull up the app for camera, at least in theory. Seek thermal. Yes, I would like to look at this thing. All right, so we're gonna just look when it wakes up. Here we go. Wake it up. Wake it up. And we're gonna look at this board and just kind of see what kind of resolution do we have without that. Let's make it less boring to look at this, and let's get this working. All right, we're gonna say, show me this, and it's gotta wake up. Ah! Not text. That's the hazards of live streaming. All right, allow. Yes. Yes.
There we go.
So here we go, and we're gonna click over to hand cam. Where are ya? Click it. There we go. All right, so let's see. So this is the resolution that we get. Let's move that. So this is about the same kind of resolution that maybe a little bit better than I remember with my old FLIR 1 cam. Like you can tell as you kind of scroll down, it will reset the temperature to show you kind of like the hottest thing in that frame. And you could kind of say like, okay, yeah, something, you got a hot spot somewhere over here. And that's, about like somewhere over there. And that's about as good as we can get. All right, now let's try it. Why don't you set this up here with your macro. And this is its first test run, right? This is its legit test run. All right. Okay. And we're gonna plug it back in, and let's see how the resolution changes with the macro lens. All right. Now we can see like really a lot more crisp resolution. Can you see that over there? Let's move it a little bit more. So what I like about this is that you can kind of get down to the level of the component. you can see these like dark spots. I'm not sure that this camera is focusing as well as I'd like it on the image that on the iPhone, but in person, all right, let's turn that away. There we go. All right. This one we found after testing, like we tested a $2,500 FLIR, and this one was really superior. Let's see. Look at that. You can really get like crisp resolution. I really wish that YouTube could pick that up. It's kind of color balancing, and I don't think I'll be able to change it from here. But you can see like on here, like, all right, there's tiny little guys here. There is a coil here. There's 2 chips here. And then this is, I think this is a chip because of its structure. If it were a capacitor, I could just see it. It would be much smaller. Just kind of like look up and see like what kind of resolution we can see in general. So let's see. Yeah, like you can see, maybe there's also, look at that, you can just recognize that's chestnut for sure. Okay, so maybe we've got some corrosion under chestnut as well, which makes a lot of sense. This is just a water damaged phone that has a lot of water. Let's look on the other side. So this one is, I really like it, and this is what we use every day. See how you can see like individual capacitors there at the power management chip. All right, so there we go. And let's put this back on. So let's see. I like it, I think. Yeah, that's really cool. Great job. It's definitely on there, and yeah, I like that a lot.
I think you can even get it off.
You got it off.
I'm
gonna break it. All right, because that's tough, right? Because it's got to be durable, and yeah, yay! Great job, our intern Anna, on your dangly dongles and your 3D printed macro lens. So very good. It says, now that's very cool, says Michael. Very, very good. All right. Wow, Anna, that is amazing. Oh, cool, that looks amazing. It really worked. Oh my goodness. They're impressed. They're impressed. So good job. And if you have a microsoldering shop and you are having trouble finding people that you can teach to microsolder for you, or you are having trouble looking for good technicians that can just do disassembly and reassembly. You know, it took maybe 5 seconds to teach Anna how to disassemble and reassemble stuff, and we found Anna by going down to Cougar Tech, the local high school robotics team, where these guys, they work on similar projects during their season, and then during the off season, like the summer, then these guys are looking to build out their resume and kind of explore things and see what they want to do. And it's really great to be able to kind of blend, you know, giving local teens opportunities to be makers and fixers and to learn stuff and to see what it's like to work in a business and see what it's like to, you know, run a business and see what it's like to make up products. And it's really, really fun, and it really helps us a lot. So Anna has been a great resource this summer. I'm so glad that she joined our team. And I encourage you to go down and talk to your local high school robotics team and get some of those guys into your shop and expand what you can do. Look around for what else in your community can you fix. The Dongle project was super fun, and so is the macro lens project. So there's lots more that you can do beyond just looking for bad caps and changing chips and TriStars and audio IC. So get busy, and we'll see you next time. And then we're gonna hit stop streaming.